This is Looking Forward for Physics 306 for Friday, the 31st of January, 2014. As you get ready for class on Monday, I'd like you to think about three different problems. The first problem is sort of your standard parallel plate problem. Imagine I have two parallel plates relatively close together, separated by a distance d. Each of them have an area A. Let's say the top plate is filled with positive charges, and let's say the bottom plate has negative charges. My question is, for this plate, what is the potential difference, delta V, if we know the surface charge density sigma? What is the charge on the plates? And finally, as a result, what is the capacitance? If we know these things, we can also ask, that's question one, we can also ask question two, what's the energy, potential energy, stored here, either in the form of the charges or in the form of the fields, and how do those compare? The second question I'd like you to think about is very similar. What if instead of a parallel plate capacitor, I had two spherical shells? Let's say that the inner spherical shell has a charge plus Q, the outer spherical shell has a charge minus Q. The inner spherical shell has a radius A, the outer spherical shell has a radius B. And again, what are these quantities? Charge, potential difference, and capacitance. What is the energy stored, and how do those energies compare? From these, we want to ask the question, are both of these, the charge version and the energy version of the energy stored, are they both meaningful? Do they both always work? And if so, under what conditions? The second question we want to ask is, when we look at these, can we get a sense of what the capacitance of something should be simply by looking at it? We'll talk about those things and more when we get together on Monday. See you then.